Hello world, this is Tom from Tutor Bros. Today we are going to take a look at the Law of Detachment and the Law of Syllogism. Now these two laws are very similar, but the main difference is that detachment has only one conditional, while the syllogism has two. And with that said, let's take a look at an example for each one. So the first one, called the Law of Detachment, sometimes referred to as modus ponens in philosophy circles, states that if we take a conditional statement and then affirm the hypothesis, then the conclusion necessarily follows. So let's take a look at the example given. The first statement is the conditional, if Socrates is a man, then he is mortal. So again, this is just a conditional statement, which we can write symbolically as P arrow Q, which reads if P, then Q. And then again, we affirm the hypothesis. We simply state that the hypothesis is true. So the hypothesis here is Socrates is a man. So that will just be our second statement here. Let's see. Socrates is a man. Okay. And since we're just affirming the hypothesis, when we write that symbolically, we just write P for the second step. All right. And then the last step would be to affirm the conclusion, because if the hypothesis is true, then the conclusion necessarily follows. So the conclusion here would be, therefore, bear with me, Socrates is mortal. Okay? And symbolically, we would write that like this. So we write a triangle of dots here that indicates the word therefore, and then we just write Q for the conclusion. All right, so again, law of detachment, we affirm the hypothesis to determine the truth of the conclusion. So we say, if Socrates is a man, then he is mortal. Socrates is a man, therefore he is mortal. All right, so that's the law of detachment. Now we'll take a look at an example using the law of syllogism, which again is very similar to the law of detachment. Only difference is that here we have two conditionals that are connected. So in this example, the first conditional is if 16 is divisible by 8, then it is divisible by 4. So we start symbolically with our tried and true if P, then Q. And then the trick here is to notice that the conclusion in the first conditional is the same as the hypothesis in the second conditional. So we move the conditional down from statement 1 down to the hypothesis in statement 2. So now the second step would be if 16 is divisible by 4, then it is divisible by 2. So since the conclusion becomes the hypothesis in the second conditional, we bring down the letter Q. So we say if Q, therefore R. Okay. Then the third step in a syllogism would be to affirm the original hypothesis in the first conditional, which was 16 is divisible by 8. So we'll just bring that down right here. 16 is divisible by 8. And remember, since that's the original hypothesis in the first conditional, symbolically we would just write P. And since we are affirming the original, and Q follows from P, and then R would follow from Q, then we can affirm that R, which is the conclusion in the second conditional, is also true, or it follows necessarily from the fact that P is true. So then we can just affirm that 16 is divisible by 2, right? And then symbolically we would write that as therefore R. So we can see how the logic in these statements kind of works its way through from P to Q and then Q to R. So all we have to do to establish R is to affirm P.